All right, welcome everyone to our next session. We have AI and modern security operations, hype versus reality. This is going to be presented by Clint San, who is a Senior Vice President of Product at Corelight.
All right. Feet hit the stage, audio's on. All right. Yeah, thank you. So good afternoon, everyone. So as she mentioned, I'm Clint. I lead product at a company called Corelight. We're a network detection and response company. Our booth is right over there. Just this morning, we did a press release advertising a much closer relationship even than we had before with Mandiant folks. Our technology is being used to power managed defense, for example, the service offerings from Mandiant. So a lot of information over there. I hope you come over and chat with me and the rest of the team about it. In particular, what I'm going to share with you guys in our talk today is all around this notion of artificial intelligence and machine learning and trying to get to the heart of the hype versus reality equation. If you were at RSA, I was at RSA, and you could not bump into someone who did not want to talk about AI. In particular, ChatGPT had exploded back then, and there are a lot of predictions about the future of everything changes in security, right? A lot of things about it. So I wanted to share with you some unique perspectives that we have working with some of the most sophisticated cyber defenders and sort of what's the real world practical implications around different types of AI or machine learning technologies, right? So let's jump in. So there is, in my position, getting to work with field teams a lot in what customers are looking for in RFPs. You get these questions about machine learning. Do you have it, right? That's the criteria, a buying decision for a lot of folks. Do you have machine learning? Another common question is, how many models do you have? How many machine learning models are there in a technology? As if 13 is great, but 14 is bad kind of thing, right? So there's a lot of sort of belief systems about, I think a lot of the vendor community honestly has driven this idea that AI is going to solve all problems, and they have some AI, and they have so many models, and therefore they can secure you the best. There's actually a survey here as well, quoted, it's a couple of years old now, where 40-something%, nearly half, I think it was 47%, of CISOs responded to this survey, cited the one thing they thought was going to save them from nation state attackers was machine learning. If they had to put all of their poker chips on one part of the table, and the list included many other things about different technologies, cloud and automation, so on. That was the thing, right? So in some of the quotes in this survey, people are talking about it's like a silver bullet, right? It's magic. It's AI. So what can we sort of dig in here to really understand this hype versus reality? You can see a number of quotes from more of the practitioner types. So what you'll often find in these surveys is that the C-level is sort of buying this idea, not that you guys would, but other C-levels. They're sort of buying this idea that it can automate magical things, and therefore you'll need less people, right? And lower your operational costs, and less people in the SOC, you can do more with it, that kind of thing. And then you talk to the actual analysts, the actual people working on it, and they're actually not too ML friendly because they look at it as busy work. I got to chase down these alerts that may or may not be relevant, right? So they look at, is there a lot of false positives? So back in those RFPs, you get this kind of dichotomy between, give me ML, and then you get but no false positives, right? And that's the sort of dance that we go through. So what can we learn from Corelight customers in particular to help cut through all that hype versus reality? So first, why listen to me about this at all, right? Who is Corelight? So if you're not familiar, there's a project called Zeek. It's an open source project, been around for decades. Zeek is like a Swiss Army knife for network security monitoring. So it's able to do high performance analysis on the wire and kick out a very rich structured set of logs, right? So NetFlow has these couple fields in it. Corelight logs are enriched with all kinds of metadata about what's going on in the network. It does file carving, right? It does a whole bunch of things. And the founders of Corelight built Zeek. So Dr. Vern Paxson, who started the Zeek project, is running our research labs. So throughout the history of the company, our founders have spent decades working with tens of thousands of users of this Zeek project, which is mostly used in what we would refer to as the high-end or elite defender tier. These are people with 50 detection engineers just within their own group. They have large investments in data lake infrastructure, right? So you have air gap networks for security, mission security, and so on. So it's a pretty high-end group of people that we get to serve, right? And in the service of those folks, generally we observe a certain design pattern as relates to network security. So they're using Zeek in terms of network security monitoring, right? So they're generating all that data. They use it for proactive threat hunting. They use it to build their own analytics. They use it for investigations. They're also using some level of PCAP, usually begrudgingly, right? The NetOps teams have a PCAP infrastructure, but they only store a little bit of that because they're using it for outage sort of investigations, not a security context, whereas the security teams want to go way back in data, right? Which is not a cost-effective way to do it. So they're using some amount of PCAP, but not maybe thrilled about it. And typically, the high-end customers that we observe are using Suricata, which is an open source network intrusion detection platform. So that's kind of forms the core of the three elements of this design pattern we see when I say the high-end or elite defenders. What you start to see as well, obviously over the years, is more and more of this notion of AI and ML, but we see it in our customer base very inconsistently implemented or even thought of. So what do I mean by that? So this is how I've bucketized what we hear from the elite defender organizations, in particular about ML. And we'll talk about the large language model, GPT, BARD style stuff in a minute. But in this context about machine learning, this is what we hear from our customers, right? They have three sort of buckets of use. One is detect better. They don't like the things that they're getting. They want something better. And usually this is code for false positives, right? They don't want to chase false positives. The reality is, if I were to ask those customers, what is a false positive, there's an array of answers I'm going to get, right? Some people think, don't tell me at all, or it's a false positive. Other people think, tell me, but it really wasn't that important, so that's a false positive, that kind of thing. So there's a sensitivity about false positives. Detect more is usually like a MITRE detection gap issue, right? We're very good at the endpoint. We've got CrowdStrike and so on at the endpoint, but we're missing the breadth of what can only be seen at the network, right? So we're looking to get more TTP coverage, and we need network visibility to do it. And somehow there's this idea that ML is always the best way to do that, right? And you've also got this third use case, which is usually more driven by the C-level, which is around automation. Can I do more with less, right? Can I have less folks? So when I've surveyed our customer advisory board, and this was a C-level audience, what would you guess was the most prevalent, most popular thing that they wanted us to do with ML? You could get 1, 2, or 3, right? 1, 2, or 3. 2, I hear mostly 3s. So what's interesting is that the high-end folks, these are national infrastructure, energy grid, banks, that kind of thing. They were all about detect better. Again, this is the C-level. Once you get to the sort of everyday enterprise, right, the people who are not funded in that kind of activity, they're actually talking about detect more, which blew me away. Because I thought these people are overwhelmed with alerts, right? Alert fatigue must be super high for a smaller, less sophisticated team. So I think the key learning was really about it's all over the map. And then, as I mentioned earlier, when you talk to the actual analyst, what do you think versus the executive, right? What would you say the actual analyst cares the most about, 1, 2, or 3? Any fingers? John, how you doing, man? You got the 2, couple of 2s and 3s. Yeah, the actual analyst community is all about detect better, right? They're already hunting around. They got plenty of alerts, right? They're not looking for machine learning to find that one attack group that may or may not be in their environment and all that. So what does that lead us to in thinking about technology and our approaches, right? What's the sort of reality-based view? This is a framework that our researchers use to think about what kind of detection capability should we leverage for a particular outcome that we're solving for, right? So if I take you through this, right, there's going to be a schema of different types of techniques, right? So IOC, bad IP, right, that kind of thing, all the way through different types of machine learning models. And then you have a number of different criteria. So back to the RFP stuff. How many ML models do you have? This is not a criteria, right? In fact, you can use supervised machine learning to detect a thing fairly simply. Is this thing there or not? You can do that. So I can give you an ML model count of 2,000 models if you'd like, but it'd be the stupidest thing we could do, right? It's incredibly inefficient in terms of development time. It takes a long time to actually create those things, to get the training set of data, to train it. So there's this bizarre game on the hype side of the equation about more ML models, the better. The other side of those RFP conversations I told you about was the false positive thing, right? People want lower false positives, and there's some disagreement in terms of what that even means. Well, if you look across the map here, confidence is a good indicator of false positives. Would you imagine that something that is probabilistic would have higher false positives, depending on your definition, than something that is deterministic? I might make that kind of assumption. You've also got this notion of expressive power. Expressive power is saying, what can we actually tell the analyst about this thing that is useful, right? So in IOC regex, right, hey, bad IP, we saw it. I mean, I can tell you with some certainty, it's deterministic, that that was there, but I don't know if you should care, right? I don't know anything else about it. Versus a machine learning model, I could probably tell you a lot about the traffic and its patterns and different scores that the algorithm used to produce this thing. So there's much more expressive power in ML, but that doesn't necessarily mean it's not a false positive, right? In fact, many of the analysts would tell us that the more sort of nebulous information you get at a generic level, right? So generic, the more time they waste, right? Versus a narrow data set or collection of alerts, much more efficient use of time. So our main takeaway from working with customers as relates to that common thought around detection efficacy is you really need detection in depth, is our marketing way of saying that. You got to have a balanced view of this entire thing. And anybody that's looking at an NDR-like solution and thinking this is all about ML doesn't understand what they're asking for, right? That's my main conclusion from this. So part B, LLMs. So I talked about RSA and how often this was a topic of conversation. I did a customer advisory board shortly after that with the same set of high-end Defender folks, and we dug into this. What are you guys thinking of this? Are you scared of it? Do you see it as a powerful thing? Overwhelmingly, and somebody at lunch, here we are, we were talking about this idea of default deny. Overwhelmingly, folks had an initial view of this as we're just going to block it, right? Attackers are using it to generate targeted phishing attacks that read much better English than they're able to write on their own in many cases. People may be putting our source code or other data into an LLM chat window. We're just going to block it. I did a follow-up meeting with those same folks a couple months later, and they're all allowing it. So the sort of notion of productivity and the use of experiments in the SOC is driving a lot of value that they didn't ultimately realize. So I wanted to crowdsource for you guys, what are those things people are doing with it that they find so powerful from a security perspective in the high-end Defenders, and how might you think about it? So this is that same sort of notion of use cases from an LLM perspective, right? So if you don't know that acronym, we're talking about things like Google Bard, right? So the first one is around alert explainability. And most folks, when they think of these kinds of experiences, because they're chat window oriented, they're thinking about use case collection number 2, right? An interaction, ask a question, get an answer, ask a question, get an answer, that kind of thing. But the notion of explainability, because LLMs are really good at summarizing lots of data in as many words as you ask them to, this has turned out to be a very powerful way to drive tier 1 SOC, essentially efficacy, right? Because you can take a very complicated situation, ask an LLM to explain it in 3 sentences, and it does. And it does a pretty good job at it. So in terms of getting more value out of tier 1 analysts, which allows your tier 2 and tier 3 to reinvest their time in threat hunting so that you can get sort of ahead of the bang, right? The left-to-bang sort of notion. That's really where a lot of them are seeing the power. The third use case bucket is around new insight, and this kind of goes to anything AI and ML. People think it sort of magically finds all kinds of interesting things you could not otherwise get. And for many organizations and even our competitors, they focused on this idea of detecting that it's in use. People are scared of it, they don't like these kinds of things, so they want to detect that it's in use. Well, I mean, if you have a proxy server, you can detect whether that's in use and exactly who's using it. That's not necessarily super interesting. And it does have a pretty interesting analytical effect in terms of having it surface new insights, but that also comes with what's called hallucination risk, right? Are you going to trust the thing? And does that turn into a false positive because now you're chasing things that an LLM hallucinated based off of a training data set, right? So here's how we thought through this and ultimately are working with our customers to drive value at that high-end tier. So the first really comes down to data, right? Most LLMs, in fact, the big commercial LLMs, they're trained on a data set that it's not current, right? If you got a CVE that happened last week, it's not going to know about that, right? If you've got a proprietary data format that comes with your firewall or your IDS or whatever, it's not going to know about that. But because we base our system on Zeek, which has been around for decades, the LLMs understand it pretty well. Suricata as well. Suricata signatures is a whole language that an analyst can use around building these signatures, and it's not always human readable. So we looked at this explainability concept, and here's what we built. So first, there's this idea that, look, we have many federal customers, we have many folks who are going to block it, right? So despite a lot of them shifting towards using it. So first thing we wanted to say was, let's not need them to allow it. So what we're doing in our system is we pre-process the prompts. So for the hallucination risk component, our researchers do all the vetting and prompt engineering. So they're developing pretty high confidence prompts. They're doing the testing to ensure that there's low hallucination risk in it. We preload that into the system so that the analyst in our console is basically working out of a prompt cloud, as I call it. They click the button, the answer comes back. There was no live connection to an LLM from that browser. It happened on our backend and with minimum hallucination risk. And this use case that we focused on first was Suricata rules. So if you've never seen a Suricata rule, that would have been a good slide to make. Shame on me. It can be pretty complicated. And even folks who write these rules have told us they look at a Suricata rule in the middle of an incident and they go, so now they're back into Google, they're looking at reference documentation. In our product, you hit the button, basically ask LLM, and it comes back with a short human readable paragraph of exactly what that thing's doing. Super powerful. And again, even the folks who have been using Suricata for decades, who write the rules, once they start using that capability, they find they can't do without it. It saves them so much time and efficacy. So, in terms of how we started the session, thinking about what are those high-end elite defenders doing with AI and ML, and what might you take away? The first category was around the notion of detection, right? The constantly chasing for, I want more ML, but I don't want the false positives. It's really a false question, right? In my mind, this is more about detection in depth, using the right tool for the right job. That's the conversation that you should be having with your vendors. The second piece here around LLMs is there's a lot of security positive in LLMs, right? This is not something to be afraid of. Many folks are leveraging their DLP installations to sort of help mitigate that risk of someone putting source code or confidential information. That's a perfectly valid approach. But there's a number of experiments that are also driving a ton of efficacy with low hallucination risk. And hopefully the example of how Corelight has done it gives you some ideas on how your teams might work better with it. So that's what I had for you today. Again, I'm in the booth right over there. If you want to go through questions, talk about your use, I'm happy to chat. Thank you.